Hey guys, welcome back to the channel again. And in this video, we will be seeing what is copy, deep copy, and shallow copy. And we will be doing some of the hands-on how you can declare and call a function. Then at last, we will be seeing what is generators, iterators, and what is iterables object. But before going ahead, we will have a quick recap what we have done in the previous session. So in the previous session, we were talking about what is list and dictionary comprehension, what is break, continue, and passes statements, as you can see. And we were doing some of the hands on how you can handle the exception by try and except block, I guess. Yep. And then we talked about raise, right? How you can customize your like error, right? You customize how you can raise a customized error, okay, by raise. Okay. Then yeah, this is what we have done in the previous session. So we will now see what is copy and deep copy and shallow copy concept. Okay, so before explaining anything, let me declare one thing, the list one. Okay, and I will give four elements here, and then I will declare one more list, and I will just assign list one here. Okay, so I have assigned two variable. Okay, I have declared two variable. One as list one, and then we have list two. In both the element, I have one list. Okay, same list, right? Now, if I want to change uh, uh, three element, right? What three element by five? Okay, so what that mean? Like in that list two, right? I have three here, right? I just want to replace this three with five. So how you can do? So if I will do list three or two, right? At second index, I will got three. So yeah, and now I want to change it by five. So yeah, it, it got replaced, I guess. So see, it got replaced. The three got replaced by five. That is like that is what we want, right? But what if I will do list one? See, like I have changed in list two. I didn't test list one, right? But the value got replaced in list one as well. So I we don't want that. We want an like we want to just we just want to replace the value in list two, not in list one. But here in this scenario, uh, both the value got replaced. So first of all, the question arises why? Uh, the this is because when you declared like this, let me open my whiteboard and let me have one thing here, here, and we have like this. Okay, one, two, two, and three, and four. Okay, first we have declared. First we have declared list one. List one is equal to this. Okay, so it got the list got saved in memory location. Okay, this is, let's suppose, your memory location. Okay, and in that memory location you have one list with 1 2 3 4 elements. Okay, then what we have done, we have done list 2 is equal to list 1. Okay, so now what is happening, that list 1, okay, and list 2, okay, both are referencing to the same memory location. Okay, to the same memory location where you have 2 3 4. Okay, so no matter like whatever you change in list 1 or list 2, it will be reflecting in both of the list, in both of the list. Okay, so if you will do like this, just understand like just try to understand this concept. Okay, like this, like let's suppose you have list one. Okay, you have any element. Okay, let's suppose 1 2 3 and 5. Okay, okay, so this all this will be stored somewhere, will be stored somewhere, will be stored somewhere, stored somewhere, right? Okay, so let's suppose it got stored in memory location like this. Memory location, okay, like this. 1, 2, 3, and 5. Okay, then we have done like list 2 is equal to list 1. Okay, so now what happened, that list 1 and list 2, okay, both will be referencing to the same memory location. So no matter whatever you changed in list 1 or list 2, it will be reflected in both of the list. Okay, that is why like that is why the value of list 1 also got replaced. What happened, you did like list 2, right? List 2 at second index we got 3, right? You replaced it by 5, right? So this 3 will be replaced by 5, right? So what happened? Now in the memory location, let's suppose here, now in the memory location, you have this value 1, 2, and 5 and 5. Okay. So when you will print, when you will do list 2, this value will be referenced, and in list 1, this value will be referenced. Okay. I hope you got the answer. So uh, now you have seen this, right? I changed in list 2, the value got replaced in list 2 and list 1 out as well. Okay, now it is a simple copy, or I will be simple assignment, right? Okay, this will be, I will say this is simple, I mean, or copy, you can say. It is not copy, or it will be assignment, but let's say, okay, it's a simple assignment or copy. Now what is shallow copy? Shallow. Okay. Now in shallow copy, if I do the same thing, copy, let me copy this, but I will not assign like this. I will do one thing. I will use dot copy. Okay. When you have to use shallow copy, you will do dot copy. Okay. Now in list 1, what we have like this, in list 2, what we have like this, and let's suppose in list 2 at 0 index, what we have 1. Let's suppose I have to change at 0 index by 5. Okay, so I will change at 5. Okay, so what we have in list 2, 5, 2, 3, 4. Okay, in list 1, okay, 2, 3, 4, 1. So I think now the problem got solved, right? Okay, let me do one more thing. In list 1, let's suppose I have 1, 2, okay, and 3 and 4. Okay, and list 2, list 2 is equal to list 1 dot copy. Okay, before doing this thing, uh, let me tell you. Now here you can see I used dot copy, right? In list 1 I got this, in list 2 I got this, both are the same thing, right? 1, 2, 3, 4, 1, 2, 3, 4. Okay, now I changed what we got at 0 index. I got 1. Okay, yep, at 0 index I got 1. Okay, I changed that one with 5. Okay, so yep, 5, 2, 3, 2, 5, 2, 3, 4. Okay, the value got replaced, and list 1, nothing got replaced. Okay, so this is what we want, right? And you might be thinking like problem got solved, right? But let me do execute this. Okay. Mm, what is there? 2, 3, 4 plus 1. Okay. Let me do one thing. What happened? backspace string, not tuple, just tuple. Wait a minute. Yeah. Yes. Uh, one, two, one, two. Yep. And we have three and four. Yep. Same thing I was doing previously. Okay, no problem. Now I have this. So in list one, I have this. Okay. And in list two, I got this. So one, two, three, four, and one, two, three, four. What is happening? I have one list. Okay, inside that list, I have two lists with one, two, and three, four. Two lists. Okay, in both of the list underscore one, list underscore two. Okay, next suppose in list two, so at zero index, I will get one. What I will get at zero index? Okay, this because at zero index I have this list. Okay, uh, I will have this list. Okay, and now if I want to change one here, so yep, again I will get one and I will change it by let's suppose five. Okay, now at list if I will see what we have, so underscore two, yep, the value got replaced. But see here, the value got replaced in list one as well. So previously you might be thinking like, oh, the problem got solved, but what is happening here? I did the same thing, but now the value got replaced in both this list, in list underscore one and in list underscore two as well. How? So in a simple word, if I say, or in a layman word, okay, so in one line, okay, so in one line, if I want to say, it won't work in the nested lists. The shadow copy doesn't work in nested lists. Okay, that's the one line. Like if I have to say in one line, okay, in nested list, it won't work. Okay, but in the same hand, if I will do one thing like this, append 5 and 6, 5 and 6. So list 1, list 2, yeah, I got one more list, okay, with 5, 6. And that is what we have done here, okay. But if I will do in list 1, okay, now somehow like it is a desirable output, like because I appended in list 2 and the value got appended, okay, 5, 6. And in list 1, like list underscore 1, the value doesn't got appended. Yeah, good thing because I didn't append it in list 1, right? But whenever I'm trying to change anything, like here I have changed, right? I have changed, the value got replaced in list 2 as well as list 1 as well, okay. But when I appended in list 2, okay, the value got appended only at list 2, not in list 1. Let's suppose I will do like this. 3 and 2. So let's see. Yeah, this is what we have done. Okay. So 3, 4, 3, 2 got appended in list 1, but not in list 2. So remember one thing, when you are doing a shallow copy, okay, and when you are manipulating anything, mark my word, okay, manipulating anything, okay, not like appending anything. It will work absolutely fine in while you append anything, okay. But when you are manipulating any data like which is already defined, okay, it will reflect, okay, in both of the list, in list underscore 1 and list underscore 2. And that's what we have done, and that's what we have, like what I had showed you, right? Like here I manipulated anything, so it got manipulated in list 2 and as well as in list 1 as well, okay. But when I append it, it won't affect, it worked absolutely fine. So while you were doing while you done some like manipulation or reassign the value, okay, so what is happening in the in the in the backend or in the core side, it is still referencing the same memory location. How it will be like, uh, when you declared, okay, when I did a shallow copy, okay, and we have created list underscore 2 with the help of list underscore 1, okay. So once you have declared, okay, so inside you have that predefined, right? You have defined this, okay. You have defined this, okay, here, okay. And now you have shallow copy to this list underscore 2. So whenever you will manipulate predefine whatever is defined already, okay, it will affect in both of the cases, in list 1 and list 2 as well, okay. But if you're appending anything, it won't affect. As simple as that, okay. So, and if it is not a nested list, like this is what I have shown you. It will, I will write here, it will work fine with list, okay. Simple list, okay. But but with nested list, it won't work. Okay, so what that it mean? You have seen, right? I have declared list 1 and copy that with list 2, okay, and we manipulated here. Like at 0 index, we have declared, we have replaced the 1 value with 5, okay. So list 2, we got 5 2 3 4, and list 1 1 2 3 4, okay. Everything was working fine, okay. The everything is good, okay, here till here. But when we got like nested list, a list inside a list, okay, a list inside a list, it is not working fine. It is like when you are appending anything, it work absolutely fine, okay. But if you are just manipulating any predefined data, okay, it will reflect in both of the list. So what is the final how you can say, what is the final solution for this? The final solution for this is deep copy. So import copy, okay. And let's suppose I will do one thing here. I'll do this, okay. And then we have list 2 is equal to list 1, or copy dot deep copy, and we have list underscore 1, okay. And we have list 2, okay. And we have list 1. Now whatever you do in list 2, right? Let's suppose we have this, right? 3 4, right? And let's suppose, um, I'm talking about this. At one index, I got 3 4, right? And then we have at 0, what we have? We have 3, right? Let's suppose I will change this. I will change this with 6 value, okay? Value 6, okay? Now see, and list 2, I got 1 2 6 4. Previously it was 3 4, right? And list 1, what we have? 1 2 3 4. Now whatever you do, whatever you manipulate, now it will work absolutely fine. If you changed anything in one list, it will reflect in that list only, not in another list. And why it is happening? When you deep copy, right, it will create separate memory location like this. When you deep copy, when you will deep when you will do a deep copy, right, when you will do a deep copy, let's suppose like this. So whenever you have a deep copy here, concept of deep copy, like suppose whenever you do a deep copy, okay, and you have declared one list underscore 1, and you have 1 2 3 and 4, okay. And when you use like this list 2, okay, and you use copy dot deep copy, and you have list underscore 2, what is happening that in memory location, what is happening? You got two lists, one, two, three, four, like this, and one, two, three, and four like this. Two memory location, and one will be referenced by list one, and second will be referenced by list 2. So whatever you do, whatever change you will do, it will reflect to this, and whatever you change, you change in list 1, it will be reflected here. Okay, so both have different memory location, so it won't affect anywhere. Okay, so this is the concept of deep and shallow copy. Okay, I hope you got it. So if you haven't got it, just do some of the hands-on. Okay, just remember in one thing. Okay, when you assign like this, okay, just when you will assign like this, okay, it will affect whenever whatever you change in one list, it will reflect in another list. Okay, when you use deep copy, oh sorry, shallow copy, okay, it will work absolutely fine when you don't, when you have a simple list, you don't have a nested list. Okay, okay, when you don't have you are working with a simple thing, you, if you're not working with anything nested here, it will work absolutely fine. Okay, but if you will have a nested list, okay, or nested objects or collection, okay, then it will give you a problem. Okay, as you can see here, like we were changing the in list 2, and it got reflected in list 1 as well. Now when you're using deep copy, right, let me write here. when when you're using, when you're using deep copy, you gotta do different memory locations. Okay, so it will work fine in every case. Okay, so when you are using deep copy, you got a two different memory location, and it will work absolutely fine. Okay, so this is the concept of copy, deep copy, and shallow copy. Now we will be going ahead with uh, function. Okay, so in today itself I was starting with the function, but I thought like deep and shallow copy is also important, right? Because I already told you what about list, dictionary and all those stuff, and I thought like it will be more suitable if I taught you like what is deep and shallow copy here. Because if I will like talk it like at last, it doesn't like it doesn't seems like good, right? So I just taught you here. Now the main topic of today is function. Okay, function here. Now, if how you could, let's see the syntax first. How you declared any function. Okay, so this is the function. This is how you define function here. Function name, parameters, and the block of code. Your block of code here. Okay, so first thing we will see why we need function. Okay, and what is the advantage of using function. So remember that thing like while teaching you loops, right? For loops, oh sorry, for loops and while loops, so what I told you, there's a concept of try, do not repeat yourself. So let's suppose you want a specific code, you have written one specific code, and that code uh, got like you want to use that specific code in in 3 4 times in different location. Okay, but you don't have to call directly, you want to call in like certain condition, you like if certain condition got satisfied, or if certain condition got occurred, okay, then you want to call it. Okay, so like let's think. Okay, you have written one code. Okay, one where it where you have just using if else condition. Okay, if that is a prime number, okay, then you want to call a specific code, and you have to do specific tasks. Else you don't want to call it, else leave it. Okay, and let's suppose, like, I'm giving you a very layman kind of example, or very like basic example, because if I uh, talk to you about modules and all the other stuff, now you will be getting confused. Okay, so just remember in that way, function is a block of code, okay, which you want to execute when certain condition occurred, or you want to call it whenever you want. Okay, you have written one code, you just uh, stored somewhere, and you want to call on a specific occasion, or whenever you want to call it. Okay, I will call, like, whenever I want to call it, then that code should run. Else you don't want to run it. Okay, then how you can do it? Let's suppose, let's have a basic function how you can define. So it will start with def. Okay, def is a keyword which is which specify that you are now dealing with function, or you are declaring function. Okay, def is the function. Okay, and you are just returning. Okay, now what is happening? What I have done here. So def sum. Okay, now what that it mean? So def is your keyword which specify that now, okay, you are dealing with function. Whatever you will write from here itself, it will be under function. Okay, sum is the function name that you have declared a function name. Then this is argument. Okay, that function take two arguments, a and b, and it will return a plus b. Okay, so this is function declaration. Function function declaration. Declaration. Why this? Okay, declaration. Okay, sorry if spelling is wrong, but yeah. So this is function declaration. This is how you declare a function. Okay, now how you will call it. Let's suppose I will do one thing, one and two. So what output I got? I got three. So how? I have given two arguments here, like sorry, two parameters here. Okay, two parameters here. Okay, two parameters here. Okay, and I have given two arguments. Like, what is the difference between argument and like parameters? Just simple way. Okay, while declaring, while while declaring the function, the function you call it parameters. Okay, while calling, we'll write here, while calling, we call it arguments. Okay, arguments. Okay, so what does that mean? So whatever you define, like you define a and b, so that function will take two values, a and b. Okay, so this is parameter. When you declare this, okay, you call it as parameter. So now this is a parameter, and now when you will call it, how you will call it? You will write a function name, then you will pass, like, whatever a parameter you give. You have two, right? So you will pass two values. One here, this is a. Okay, this is your a and this is your b. Okay, and then in return it is returning a plus b. So both parameters arguments both the same, the naming convention is different. So while declaring, you called it like parameters. Okay, while calling you call it as argument. So both the things are same, the naming convention is different. Okay, and in short there's one more line. Parameters are like you don't know like what value it will come, right? I can give numbers, I can give anything, right? So we call it parameters. So argument is when you know the value. So this is our argument. One is your one and two is your argument. This is the actual values of your function. Okay, so now if I will do one more thing like sum, I will sum. Okay, I will do 4 and 5. Okay, so it got you, it give you 9. But let's suppose if I will not give any argument. Okay, so you got an error missing two required positional arguments. Okay, a and b. So it is saying that function you have defined a function with a and b. So it will take the value a and b, then it will return you. So if you will give like like 5 and 6, okay, then you it will return you. And let's suppose I will define a simple mm, simple function. Let's suppose any function name. Let's suppose a function name is uh, numbers. Okay, just numbers. Okay, numbers, numbers, and in that I will return mm, anything, any number, just number two. Okay, then now I don't have to give any arguments. Okay, because here I didn't have any parameters. Okay, so if I want to call it, I will just do like this. See, okay, so like this I will call it. Okay, now let's suppose I will have one pair argument. So it will take one argument. Okay, and here you can specify any name, right? Any valid name. Let's suppose I will have numbers. Okay, then return numbers. Were you getting? Okay, numbers into numbers. Okay, then I will call square. Okay, and I will give 2. Okay, this you got 4. Then I will have square. Then I will give 4. Okay, you got 16 here. Same as if you want to declare, if you want to just declare a function with a uh, default value. Okay, so how you can give the default values. So what that means, let's suppose the default value is, so I will again do a square. I guess I will give a number as an argument. Let's suppose I get numbers. Number is equal to 2. Return return numbers into numbers. Okay. So what happened here? So still you can call it by this. Okay. See here. So what is happening here? When you specified one parameter here, number. Okay, but you didn't give any value here. So by default you have assigned 2. Okay, so that 2 will be replaced by with your original arguments. Okay, let's suppose if you will give 3 here, right? Okay, now you will get the value as 9. Okay, so by now you have specified the argument 3 here. So here 2 value got will be replaced by 3 and you will get your output. But if you will not specify your arguments here, if you will not give your argument here, okay, by default it will take 2 here. You can specify anything here. Let's suppose if I will specify 4, right? So it will give you 4. But if you will give the argument here 2, it will give you the result accordingly. Okay, so this is your by default values. If you want to give a by default values to your parameter, you can give the values like this. Okay, I will show you one more example like sum. Like we have defined the sum here. Okay, we have defined the sum here. So by default, if I will give the value here, a is equal to 1 and b is equal to 1. Okay, now if we will call c here 2, right? But if I will specify 3, 2 and 4, okay, we got 6 here. So this is the function. Like this is how you declare a function, and this is how you call a function. Okay, now we will write one good thing. Okay, let's suppose we want to check that any number no is number. Okay, is number. We have declared a function with is number. It will take uh, values, okay, and it will check if type values is type values is equal to int written is a is a number. So is a, if you want to call this is a number, type is equal to value. What happened? Hmm. Okay. It's true. Let's suppose is a number. Okay. What is happening here? How did it type? If type values is equal to int, right? What is not happening? Hmm. Let me check. Int int. Okay, just wait a minute. Int, right? Oh, sorry. I have written. Sorry. That's right. I have written like this. Okay. Yep. So this is the function. What I have done, I have just make it like string, right? It won't work. Okay. So what this function is checking? This function is taking values and it is checking whether type of values is equal to int. If it is int, then it will print like as a number. Okay. Else written, or I will not write else is not a Alright, let's suppose I will give any string values, that's not a number. So this is how you can declare a function and how you can use it. So let's suppose is a number. So you might be dealing with any list or anything, right? Where you want to check whether the element in the list is a value, is a number or not. So you can use it, right? You can use it. So how you can use it? Let's suppose I will declare a list. Okay, 1 2 3, and let's suppose till that's the string, then I will have a string, then I will have this and this, right? And I will do one thing for I in this, and then I will call this number, this number, and I will give a. So you can see. So as a number, yes, one is a number, two is a number, three is a number. Then co is not a number. Then low is not a number, and then one two is a number. So this is how you declare a function, and you will call it by like on occasionally and whenever you want to like call it. So this is something about functions. Okay. So there is one more thing. There is lambda function as well. So one lambda function or anonymous function you can say. So you can write it like this: lambda, and it will take one a and b, a and b, and it will return you. It will return you like b plus b, I guess. Yes, and then I will take or give one more thing like this: one and three. So yeah, so this is lambda function. This is how you can use lambda function. Okay, so lambda function or anonymous function you can say. So this whenever you have want to give a one-liner function, whenever you have to give a one-liner function and without a name, you can use lambda here. So what lambda? Hey guys, sorry my audio got disconnected. So where we were? Okay, so I think I told you about lambda function, right? And after that I was recording because I thought like everything is going fine, but when I like when I checked it, uh, then I got to know that like okay, my audio got disconnected. Okay, no problem. So I think like I told you about lambda function or anonymous function. Okay, don't worry, I will give you lots of example. Okay, so I just give you the brief. Okay, so don't worry, I will create one video. Okay, where we'll do some hands-on. Okay, so when we do some hands-on and all that stuff, okay, so I will give you all those like hands-on uh, lambda functions, and I will see what my thought is. Like I will first I will give you some brief. Okay, of what is Python and all that, like basic stuff, data structures, data types and all that stuff, right? And then like once I will complete till oops, right, then I will create one video where we will do like I will create two three videos where we will do like lots of hands-on. Okay, so your idea and your vision will be clear. Okay, so uh, I think I was about to tell you about iterators and generators, right? And yep, okay, so let's see args and k args first. Okay, so let's see here. So, what is args and characters? Args and characters is nothing but, let's suppose you are defining any function, okay, and you don't know the actual parameter, like you don't know. There might be one condition where you are declaring a function, okay, and you don't know like how many parameters I have to give, okay. So at that time you can use args, okay. So let me tell you like how it works. You do args and or return uh, args, and then that says multiple function, multiple arg param, I will say, okay, multiple param. Okay, and let's see if I will call multiple params and see 1, 2, 3, 4, 5, and 6 and 7. Let's see. So see, your function will take as many as argument as it will give. Okay. So what is the difference? Let's see if I will give two arguments here. Let's see. Let's see, you will give a and b here. Okay, and you will just call with 1 2 and 3. So it will give you error because you have given two parameters and now you are giving three arguments here. Okay, So let's delete it, and now it will work. Sorry, A and B. I have to give A and B. Okay, so now as you can see, but let's suppose if you don't know like how many parameters I have to define here, so you just give the arcs. Okay, and it is a naming convention. You can use anything here. The important is like when you will do a star here. Okay, you can do, you can give, it's not like uh, you can define any name here. Okay, so when you will call multiple pans, and 1 2 3 4 5 6 and 7 8, and okay, up to, okay, so the important is there's a star. Okay, there's a star. Like if you will declare a star and then a name, then it will take as many arguments as you will give. Okay, and it will return you, it will be in a tuple format. Okay, so if you want to fetch this one, like this one, okay, how you will fetch? So at zero index, that's simple, right? Let's see. So at zero index, it is returning one. Okay, now let's see when we, what is k args? Okay, multiple k args, I will say. Okay, so it will start with two stars, and let's see k args. Okay, and then return this. Yeah. Okay. So main difference is like it will take a key value pair here. So how you can give like this? Okay, A1, B2, C3, and so on, right? C3 is equal to 3. Okay, so how does multiple got an exception argument with the A? Why? Okay, let's see, 1 A, right? Uh, let's see here, and this will be C. What is happening? Like this is how to give, right? Just read them like this. Let's see how I defined earlier. I think like it is. We can give. Yeah, this is I'm giving like this. Oh, sorry. So I'm calling Adam here. So I have to call multiple args. Just define, right? Okay, let me copy this. So see, so it will take the argument and key and value, and it will return you a dictionary. Okay. So here also you can give as many argument as you have to give, but it should be in key and value pair. Okay. And this is a naming convention. Of course, you can name anything here. You can do like and give any name. Let's suppose I have given this. Okay, and then even you will call. Okay, let's see. You have to return the disk. Okay, and then you will call the same here. See, you got it. Okay, so the important is that you have double star here or not. So remember that. Remember star concept. If you will define a single star, it will be a args, and it will return. It will take the argument as tuple. Okay, as you can see here. And if you will star, if you will declare two star here, then it will take a key value pair, and it will return you a dictionary. Okay, and in both the cases, you can give as many as arguments you have to want. Okay, now the concept comes here with the generators and iterators. So let's see where that does. We will copy this. Iterators and generators. Okay, what are iterators and iterables and generators? So let's see. But I will tell you, I already have done those things. Okay, so I don't think so that I have to write again and again. So let's see the definition here. So Iteratable object, okay, multiple arguments I have to allow. Now here I have to tell you what is iterables. Okay, iterables objects are those one on which one those one which follows indexing concept and on which you can loop. So any object on any collection which follows indexing concept and on which you can loop. Okay, those objects are iterable. Okay, I will write here also if you are getting confused. Okay, so iterable objects are those one which follows indexing concept and on which you can loop. Okay, so let me tell. Just tell me whether string is a iterable object or not. Yes, it is. Yes, it is a iterable list. Yes, yes. Couples. Yes. Okay. So and there should be a many more, right? There are, I'm just giving you an example, right? So string, yes, it is a iterable object, list is a iterable object, and tuples is also a iterable object. Now what is iterator? So I already have defined here. Okay, I will take here. So in iterators, you can fetch the element by only by once. Okay, you can use next keyword to iterate. You can make iterables objects to iterator by using iter keyword. It follow dynamic memory allocation. Location I have written location. It is allocation allocation. Okay, so what that it means? Okay, so let's suppose you have the final list. Let's suppose I have the final list 2, 3, 4. Okay, and then for I in list. Okay, and in time. Okay, 1, 2, 3, 4, and if you will rerun again, it will run. Okay, as many time as you will rerun. Okay, but let's suppose what if I will do? I will do one thing. Iterator. Okay, then L is equal to iter L. Okay, then enter. Okay, and if we will check the type, now check the type. So it is a list iterator. So by using iter keyword, you converted your list into list iterator. Now for I in iter L print I. Just focus here. Okay. Now all the elements got fetched. Okay. And focus here. And I'm rerunning this cell again. See what will happen. Okay. Nothing. Okay. Nothing. So I hope you got these two words, these two things. Okay, that in iterators you can fetch the element only by once. So once you fetch the element, you cannot fetch that again until on unless you have to reassign it. Okay, let's suppose I am reassigning this. So I'm running this cell, then this cell. Okay, so I reassign this thing. Okay, so now the value got printed. Let's suppose I will rerun this again. Now the value will not print again. Okay, and you can make the iterables object to iterator by using the iter keyword. Okay, so this is an iterable object. Okay, and I have converted into iter object with the iter keyword, right? So it got converted into list iterator. Okay, and it follows dynamic memory allocation. What that it mean? So each, like let's suppose every element here, right? When you call or when you fetch those elements, so it got fetched. It is already there in the memory. Okay, and it got like printed when you called, right? But in when you declare as a iterator, right, it will not occupy space until or unless you have to, like when you will call, it will initialize in the memory. Okay, else it will not initialize. Okay, don't worry if you are not getting it. Let's suppose you're in let's suppose you have a memory, right? In memory you have stored 1 2 3 4 in a sequential manner. Okay, so one by one you are fetching 1 2 3 4. Okay, but when you will convert into iter object, it will be dynamic memory allocation. So uh, it will be fetch only that time when you will call it, else it will not be present in the same memory location or same memory space. Okay, so yeah, this is the concept. And if you want to know these things, dynamic memory location, give me a time, like give me a 2 days time. Okay, and I will get back to you on this. Okay, what is like dynamic memory location and all that stuff. So, and you can use the iter key next keyword. So what that it means, so let's suppose we'll do one thing. We'll again assign this. Okay, and now I will fetch the element by next. So I will do next, and then I will do iter l. So I got one, then I will read, and I got two, then I will three, then I will four. Okay, and five. So stop iteration. Okay, so now you cannot you cannot fetch another element. Okay, because the element got like we have four element, right? So after four it will give you throw you an error. Now what is generators? So I already defined here. Let's see the definition here. Okay, let's see the definition here. So, so generator is a function with a yield keyword which will return you a generator object which behaves like a iterator. Okay, like an iterator. Okay. Now what that mean? Let's just define one generator. Okay, which will take an argument. Okay, and for I in range of nums will come as from here, nums. Okay, and then it will return yield I. Okay, now call this generator. Okay, will give 5. Okay, and see, when you called it, didn't return anything, it returned generator object. Okay, the generator object as a function with the yield keyword. Yep, yield keyword is here, which will return you a generator object which behaves like an iterator. So okay, it returned me a generator object and it will behave like an iterator. Okay, let's see. So if it is a generator object iterator, then it behaves like a iterator, so I can definitely loop on it. Okay, so for I in generator 5, let's see, print. Okay, 1 2 3 4, right? So yeah, uh, uh, it got printed, and let's suppose I will do one thing. I will store in that var, and I will call this generator object with 5 numbers. Okay, and I will do one thing for I in var. I will try to see what is happening here. See, and let's suppose I will rerun this cell again. Okay, now you will not. Okay, so yes, it is behaving like a iterator. Okay, and let's see whether I can fetch this element with next or not. Let's see, next, and where? Yep, 2 yes, 3 yes, 4 yes, and 5 yes. Okay, so stop iteration. Yeah. So this is generator. So generators, iterators, and iterables object. I think it is clear. So iterables objects are nothing but which on which you can loop, and it should follow indexing concept. And iterator sets like these main thing, like iterator you can fetch the element only by once. You can use Next keyword, you can make any iterables object to iterator by using iter keyword. It follow dynamic memory allocation. And then it is generator the function with the yield keyword, which follows or return your generator object will behave like an iterator. Okay, so that is all for today. Okay, go on and practice and do some practice or hands-on by your own, and it will be more clear. Okay, till then, bye bye.